This lesson is on the rock cycle. Now, before we can talk about the rock cycle, we have got to talk about some of the processes that drive the rock cycle, namely weathering. Weathering wears rocks at the Earth's surface down into smaller pieces. And there are two types of weathering. We have physical, otherwise known as mechanical weathering, which occurs when fragments of rock break off due to wind, changing temperature, tree growth, water freezing inside cracks in the rock, and sometimes by other means. Chemical weathering occurs when minerals in the rock are dissolved or otherwise chemically changed and broken down by acidic water or rusting. So in earlier science classes, a lot of times weathering and erosion are kind of placed under the same umbrella, and it's just all called erosion. But to be more specific, there are two different processes. Weathering is the process that breaks the rocks down. Erosion is any process after that that moves the pieces. Alright, erosion and sedimentation. The small fragments produced by weathering are called sediment. This includes broken pieces of rock, sand, silt, clay, and chemical precipitates, which are the solid materials left behind after a liquid evaporates. If you want a good mental picture of what a chemical precipitate is, think about when you get a milk jug out of the refrigerator and you pull the cap off and you see the crusty white stuff around the opening of the milk jug. Those are chemical precipitates from milk that had evaporated, that was there around the lid, around the opening, that evaporated after being in the refrigerator. Alright, erosion occurs when the sediments are removed from the rock by wind, running water, ice, gravity, or human activity. And that's very important to point out. When it comes to weathering and erosion, any human activity counts as weathering and erosion. For example, if you were to go outside and find a rock and bang on it with a hammer and break pieces off, that counts as weathering. I know it seems a little strange. We want to think about natural processes contributing to weathering and erosion, but us humans are indeed natural things, so it counts. If we go out and we move sediments around or we break rocks down, it counts as weathering or erosion, just the same as any other process. Now, during sedimentation, which is also known as deposition, sediments are laid down or deposited and remain where they are unless they're again moved by some other agent or force of erosion. Alright, the rock cycle is a continuous changing and remaking of rocks. It's important to note that any of the three major rock types can be transformed into another one of those rock types by natural earth processes. So we have three major types of rock. We have igneous rock, metamorphic rock, and sedimentary rock. And if you're looking at the picture here, you can already see that any of those three types can become one of the other types if it passes through one or more processes. Alright, igneous rock is formed from the crystallization of magma. And by crystallization we mean cooling and hardening. So when magma under the earth or lava above the earth's surface cools and hardens, we say it is crystallized and it has formed rock. Here we have two examples. The one on the left is granite. This is a rock that makes up a lot of Earth's continental crust. It is felsic and it is lighter than the basalt that you see on the right, which is a very mafic rock that makes up Earth's oceanic crust. Igneous rock can form in many different environments. You can have magma that's under the surface of the earth that happens to cool and harden. You can have lava that's above the surface that cools and hardens. You can have volcanic eruptions on the seafloor where as soon as the lava starts hitting water, it cools and hardens really quick. And those locations can affect what kind of rock forms. So the chemical composition of the magma, what the magma is made out of, and the rate at which it cools will determine what type of igneous rock forms. All right? Igneous rock that cools underground is going to cool much slower than igneous rock that forms above ground. And then igneous rock that forms underwater is going to cool very quickly. So igneous rocks can cool slowly beneath the surface, rapidly above the surface, or even more rapidly if it happens to come out into the water. All right, as magma cools, the rate of cooling will determine how much time the crystals have to form. The slower the cooling is, the larger the crystals will be. Fast cooling produces smaller crystals or no visible crystals at all. A lot of times when magma cools or lava cools into igneous rock in water, it cools so quickly that there are no visible crystals and the rock can have a glassy-like appearance. So the size of the crystals that make up a rock are used to help classify the rock, to tell what type of rock it is. All right, moving on now to sedimentary rock, which forms from the compaction and cementing together of sediments after deposition. So you have sediments that end up piled on top of each other and they become compacted and cemented together. I like to call sedimentary rock nature's cement because that's basically what it really is. It's all these little pieces stuck together to form larger rock. Examples include sandstone and limestone. Bedding is the horizontal layering of sedimentary rocks, and you can see examples of bedding in the picture to the right. Bedding can occur in very thin layers, in very thick layers, or can also be graded or crisscrossed. So in the picture on the left we have some graded bedding. That's where you have layers in which the bigger pieces, the bigger heavier pieces are at the bottom of the layer, and as you go up in the layer you have the smaller lighter pieces. The pieces get smaller and lighter as you go up through each level. And you can kind of see that here. You can see a level here where it's the smaller lighter pieces. Then you have another layer here and you see you got the bigger heavier pieces, and then the pieces get smaller and lighter as you go up. And then we have another layer here, and you can see again you have big pieces like you had here. Here we have crisscross bedding, and this happens from wind patterns that change over long periods of time. And that way you get sedimentary layers that are laid one way and then another way, and then as wind patterns change over many, many years, you just get these different orientations of the bedding. All right, moving on now to metamorphic rock, which forms when already existing igneous or sedimentary rocks are changed by heat and or pressure below Earth's surface. So we're talking about enough heat and pressure that the atoms that make up the rock can rearrange themselves. It's not enough heat to melt them all the way, but it is enough heat to cause the crystals and the atoms of the elements that make up the rock to rearrange themselves in different patterns. And this can also change the chemical composition of the rock. Also, it's important to point out that already existing metamorphic rock can further metamorphose if it continues to undergo heat and pressure under the earth. All right, some examples here are gneiss, which is on the left, and marble, which you see on the right. All right, when a rock is exposed to extreme heat and pressure within the earth but does not melt, it is said to have become metamorphosed. And metamorphism may change the mineral composition, like I was saying earlier. It can actually change what the rock is made out of, because it changes it allows the atoms of the elements to move around, and sometimes they make different bonds than they had before metamorphism occurred. Also, it can change the texture of the rock, and it can also create these patterns in the rock that we're going to talk about in a moment. All right, foliation. Metamorphic rock is classified into two groups, foliated and non-foliated. Foliated metamorphic rock is going to have these long, sometimes wavy layers of crystal that are perpendicular to the pressure that formed the rock. You can see that back on this picture here. You can see that this rock has these layers in it. All right. So non-foliated metamorphic rock is not going to have any layers like that. It's not going to have wavy or straight layers of crystal at all. You're going to have blocky crystal shapes instead. They don't line up in any particular direction. And here are two examples. We have foliated gneiss over here, and you can see that it has these wavy layers where like crystals have kind of found each other and created these different layers. And then you have non-foliated marble here, which doesn't follow any pattern whatsoever. There are no identifiable layers at all. Alright, let's talk about the rock cycle processes, how these rock types form again, and how one rock type can become one of the other rock types. Alright, igneous rock formation occurs when sedimentary or metamorphic rock is melted down, and then later that magma or lava cools to form igneous rock. Alright, sedimentary rock can form when igneous or metamorphic rocks are weathered and eroded and then later lithified, which is a single word that can be used for compacted and cemented, into sedimentary rocks. Alright, so you have already existing igneous metamorphic rocks, or it could even be previously existing sedimentary rock that is weathered and eroded, and then when it settles somewhere and it undergoes the pressure that compacts it and cementation, it can form new sedimentary rock. Alright, metamorphic rock formation. Igneous and sedimentary rock can be transformed by heat or pressure to form metamorphic rock. And like I said earlier, already existing metamorphic rock can undergo more metamorphosis if it continues to undergo heat and pressure under the earth. Alright, so the rock cycle demonstrates the relationships between those three major rock groups by showing you how just by passing through one or more processes, one of those rock types can become one of the other rock types. The rock cycle is powered by the interior heat of the earth as well as Earth's momentum and energy from the sun. It involves processes on the Earth's surface as well as processes within the Earth's interior. Also, the rock cycle connects the hydrologic or water cycle with the tectonic cycle, which is the movement of Earth's tectonic plates that we'll be talking about in future lessons. Alright, to sum things up, there are three main rock types: igneous, metamorphic, and sedimentary rock. The processes that change one rock to another are melting, crystallization, metamorphism, erosion, and sedimentation. Any rock can transform into any other rock type by passing through one or more of those processes, and that's what drives the rock cycle.